All right, and welcome back, mathematicians. In today's video, we are going to look at solving exponential equations, and that is equations in which the unknown occurs as a part of the exponent. And to solve these types of equations, we are going to use the following property. If we have that a to the power of m is equal to a to the power of n, then we can conclude that m is equal to n because both sides of the equation have powers of the same base. So let's look at a couple of sample problems. Okay, this is non-calculator. Whenever we can, we want to first look for a common base. So in question A, we have 3 to the power of x is equal to 27. We can rewrite the 27 as 3 to the power of 3. And so now we have two expressions on each side of the equal sign with the same base, so we can conclude that x is equal to 3. Next up, B. We have 7 to the power of x is equal to 1 over 49. We can rewrite the expression on the right-hand side as 7 to the power of negative 2. That gives us x equals minus 2 as our answer. Okay, moving on. Let's pause the video and try these questions on your own. Go ahead and take 3 to 4 minutes. All right, hopefully you have attempted these questions yourself. Let's take a look at question C. So 8 and 4 can both be rewritten as powers of 2. 8 can be rewritten as 2 to the power of 3, so we have 2 to the power of 3x on the left and 2 to the power of 2 on the right. Now that I have the same bases on both sides, I can set their exponents equal to each other and finally solve for x, which is 2/3. D. Ooh, there's an extra equal sign there that's not supposed to be there. 1/2 can be rewritten as 2 to the power of negative 1. So we have 2 to the negative x on the left, and 16 is equal to 2 to the power of 4, leaving us with negative x equals 4 or x equals negative 4 as our final answer. E. We have 4 to the power of 2x plus 1 is equal to 128. So this is where you got to practice your powers of 2. If you haven't ever played the game 2048, highly recommend. It'll help you remember your powers of 2 and is a nice brain break from our IB SLAA Math. All right, so let's rewrite the left-hand side as 2 to the power of 2. I'm going to put that in brackets and keep the 2x plus 1 on the outside for now so that I don't get messed up. And 128 is equal to 2 to the power of 7. Now let's distribute the 2x plus 1 through the bracket, giving us 2 to the power of 4x plus 2 equals 2 to the power of 7. Now we have the same bases on both sides. We set the exponents equal and continue to solve for x, giving us 5 over 4. Question F. 4 can be rewritten as 2 to the power of 2, so we have 2 to the negative 2x on the left. And 32 is 2 to the power of 5, and square root of 2 is 2 to the 1/2. Now we have to combine the expression on the right-hand side in order to get the same power on the power with the same base on both sides of the equation. So we're going to leave the left-hand side alone for now. And when we have two powers being multiplied with the same base, I add their exponents. So let's rewrite the 5 as 10 over 2. So now we can add it with 1/2. And that gives us 2 to the power of 11 over 2 on the right-hand side. And now we can set the exponents equal to each other. Me minus 11 over 4 for x. All right, here are 4 more questions for you to try. And if you haven't watched that video on the hidden quadratic, I would highly recommend trying that video out before attempting some of these questions. Go ahead and pause the video, please. All right, let's take this up. So again, whenever possible, we want the same bases on both sides. The left-hand side, I am not going to touch for now. But what I am going to do is rewrite the right-hand side. The 9 becomes 3 to the power of 2. And I want to distribute that 2 across the x plus 1. So let's do that in the next line. Now that I have 2 sides with a single power on each side, I can, in the same base, I can set their exponents equal to each other. Okay, and let's make this equation equal to 0. So we get x squared minus 7x equals 0, and we can factor out an x, leaving us with x times x minus 7. And using the 0 product property, we get x equals 0 and x equals 7 as our answer. H. Let's rewrite the 8 as 2 to the power of 3. So I have 2 to the 3x on the left-hand side. And on the right-hand side, I'm going to rewrite the 16 as 2 to the power of 4, but it's in the denominator. So what I'm going to do is move it to the numerator by giving it a little negative exponent up top. And don't forget that that negative 4 needs to be distributed across the x plus 1. So let's simplify a little bit on the right-hand side before we proceed. Now that we have the same base on both sides, I can make their exponents equal. And we continue to solve for x. So we get x equals 4 over 7. Oh, there's a typo here. This should be a negative 4. Let's try that again, minus 4. So minus 4 over 7. All right, next question. So here we have 4 to the power of x squared minus 7x plus 12. We do not have the same base on both sides, but remember that anything to the power of 0 is equal to 1. So why don't we just make the right-hand side 4 to the power of 0? And now we have the same base on both sides. We can set their exponents equal to each other. And let's factor this expression on the left. And again, using the 0 product property, we can get x equals 4 and x equals 3. All right, moving on to our second last question of the video. We have here a hidden quadratic. That's right. Notice our repeating bases, 2 to the power of x. So to see it more clearly, we can let some variable a, let's say, equal to 2 to the power of x. And we can rewrite the expression on the left-hand side as a squared plus a minus 20 equals 0. And now I can factor this quadratic expression on the left to a plus 5 and a minus 4. Now that my expression on the left-hand side is factored, we can solve for a. A is equal to negative 5 or a is equal to 4, but don't forget to plug back in our expression that we subbed for a, which was 2 to the power of x. So now we have 2 additional exponential equations to solve, and we can see that there is no solution for this equation on the left because 2 to whatever power we can think of will never give us a negative answer. But we can solve for the equation on the right that gives us x equals 2. And finally, our very, very last equation, we first must recognize that this is another hidden quadratic. So let's rewrite the expression on the left-hand side as powers of 3. I'm going to change up this middle term to 3 to the power of x times 3. Okay, and if I use my exponent properties and combine these back together, I'm going to get 3 to the power of x plus 1 because there's an exponent 1 here on that 3. And to see the quadratic more clearly, we can let a equal 3 to the power of x, and that gives us a squared plus 3a minus 4 equals 0. We factor this to a plus 4, a minus 1, that's equal to 0. A is equal to minus 4, and a is equal to 1. Replace the a with 3 to the power of x. And we have 2 further exponential equations to solve. There is no solution for this one on the left, because no matter what number I raise 3 to the power of, it's never going to give me a negative value. But the equation on the right has a solution, and that is x equal 0. Congratulations, we have made it to the end of today's video. Please give this video a thumbs up and hit subscribe for more. Thank you for supporting the channel, and we will see you in the next Math Help.